Some open source code I got had a bug in it. I probably spent a month tracking down why my gradients were not in the right direction or the right sign.
Everyone who trained a model has war stories. We asked top researchers to share theirs.
I'm Kyle Houghton. I'm a fifth-year PhD student at Tufts University with a background in public health and pursuing my PhD in computer science.
And could you share a few words about your research?
So here we've trained models to predict opioid overdose deaths in Massachusetts. We found that the metrics people were using in their forecasting models for public health, they didn't capture the needs of the public health departments, how they would actually use the models. So here we propose a new metric that reflects when a public health department will intervene with a limited budget and better captures the success of that. And we also show how you train your models to optimize for this new metric.
And could you recall a moment for training that didn't go as planned?
So we proposed this new metric, how accurate is your model's rankings? And the ranking procedure is not differentiable. The derivatives are zero everywhere. So we needed to incorporate new techniques of turning this thing that's not differentiable into something that is. And there are known methods for doing this, but when we applied them, there were some bugs. There were some typos in the code. There was difficulties calculating the gradients. So yeah, I probably spent a month tracking down why my gradients were not in the right direction or the right sign.
And what was the first anomaly that told you something was off?
The models weren't training. I was training these models and accuracy at the public health decisions was getting worse with the new objective when I knew it should be getting better if that's what we're maximizing now.
Was there any observability tooling that helped you surface the issue?
No, I'm a PhD student working late at night. I was using print statements. There's more principled ways to go about it. You debug the intermediate steps of the calculation, you graph the gradients over time and see where it goes on. So I designed my own observability eventually.
And are you able to share roughly how much compute or clock time did it burn until you caught it?
These models are modest. I was probably running them on A100s. They run for about an hour. Let's say I had about 100 failures before I figured it out. So 100 A100 hours.
And what did the final fix end up looking like?
Some open source code I got had a bug in it. So I was able to track that down to the intermediate calculations and fix the math.
And is there a particular metric that or set of metrics you're now especially keeping an eye on?
I think I learned to log all the intermediate computations. It adds a ton of overhead and you can't do it in the final product because you need the intermediate gradient steps, but understanding the math and doing it by hand and following it through the computation, that was really the only way to do it.